Hello and welcome to the Boat Shed. My name is John and this boat below me is Antidote. And I'm an engineer and a sailor with a dream of fixing up this old boat to go sailing around the world. And now I've got a lot of work to do first. Last week, if you were here, we were putting down this new core material and it turned out to be super stiff, so I'm really excited about that. I think what we'll get started on today is trying to remove this first bulkhead. It's really decrepit and old, needs to go, so we'll start with that. Now it's raining really hard here today, so you're probably hearing some of that. I apologize, but thankfully we have this roof overhead, so at least we can keep working, right? We're going to start here by marking out some of the reference points down from this straight plane between the two sides of the bulwark down to the new core, because as I take out that structural piece, the first bulkhead, I don't think I'm going to lose much shape because I showed you last week how I could almost jump here where there is no brace and it only moves less than a 1/16 of an inch. Being that as it may, I still want to take some measurements here, write them down on the material so I have some baselines so I know that as we put the new bulkhead back in, we're keeping the shape. So it's roughly there. And I'll mark position of the measuring stick. And then off we go. So right here, 3.75 inches. 4.25. Okay, that ought to do it. Why am I wearing this ridiculous outfit? Well, I'm about to make a very large mess. Up at the bow, we've taken the braces out and confirmed that it's nice and stable. So now on the inside, I want to get all that cleaned up so that I can put a new coating in there. The original gel coat is cracked and stripping and falling apart. So we're going to get out the old grinder, the abrasive wheel. I think it's best if you just stay right there. This is going to get really dirty. About halfway down here, cleaning up the inside, and I have got to say, it's not going quite as I'd hoped. So the 4.5 inch angle grinder does a good job. They call this a stripping disc. And I gotta say, it works okay, but I'm a little disappointed. I was under the impression that it would remove the paint without damaging the fiberglass too much. This is really just a big flapper disc. It removes fiberglass and paint together, so I don't know, maybe I have the wrong one here, and it's spinning so fast it creates a huge amount of dust. It's like a cloud in there when this is running. That's why I'm wearing this suit. This thing actually does the best job at cleaning up the paint or the old gel coat without removing any of the fiberglass, but it's also sort of like trying to clean the bathroom floor with a toothbrush. It's such a small little tool. So I was thinking, man, I really wish I had an angle grinder with an adjustable speed because I like to run them slower so they don't make as much dust, but they can still remove material fairly well. Then I remembered I have this 7-inch polisher which has a variable speed, and then I picked up a 7-inch flap disc for this. This is a 36-inch flap disc. This one hasn't been used yet. This will have a variable speed so I can run it a little slower, hopefully remove material very controlled without a lot of dust, or it'll just, all the dust will kind of fall down instead of spraying all over the inside of the bow here. So let's give this a shot, see if we're any happier with this. This is one of those jobs you kind of regret starting. Once you start, you really can't stop, you know. I was expecting the old cracked gel coat to basically fall off with the slightest abrasion, but what I found was about half of it flaked off easily and the other half was actually pretty tenacious and difficult to remove from the little recesses in the surface. In the end, the 7-inch flapper disc on this slow setting did a great job of removing the coating, and in spots I removed the slightest amount of chop strand mat from the inside. There's no easy way or clean way to do this, but the slow speed creates big bulky particles that tend to mostly fall to the ground and can be vacuumed up after. I'm happy with this procedure and I think this worked really well. Well, that's about as much as I'm going to tolerate for today. It's a lot of work getting in there grinding away in your Tyvek suit, but hopefully I can get something to bond to this nicely now. Coming into the bow here, and this bulkhead has a really bad separation. We want to replace this whole thing, and of course all these components here are kind of holding it in. So there's tabbing for this little bit of plywood here for this removable panel. This will have to come out, these beams, are then holding in this main cross member. So with all of this out, we'll be able to then remove this piece of wood. So we can cut the tabbing on the inside all the way up and around, and then repeat on the aft side of the bulkhead, and then we can hopefully get this thing removed. At least that's the plan. We'll see how that goes. Nothing's ever easy around here. All of the mahogany solid wood braces have been removed that establish this little platform here at the very bow of the boat. Now thankfully the plywood was rotten to the point that it all separated, as has been the case on this boat so far with a lot of the plywood. And the lower skin is still on this fiberglass tabbing that was used to tab it below the plywood layer. So that actually works out really well, and we're not going to cut that off because that's going to give us a new platform to install the new layer onto. We'll just sand this down, try and get the wood removed, and leave just a little bit of fiberglass left. It looks like it's just one layer, so we're not going to do too much sanding on this, just enough to keep the platform level established when we put the new pieces down. Well, that works out in our favor. Now the same thing is happening on this bulkhead. Let me show you. Okay, for this upper bulkhead, we've already cut away the aft section tabbing, and we've gone down to here where I need to now remove this panel and get down inside. It's just a little less comfortable to work, so I'm starting at the top here. You'll see over here I can already start to pull this back a little bit. So there's tabbing on the forward end as well. You can kind of see here that there's actually like a recess cut into the plywood that they've tabbed into, which is interesting. But what I'm hoping to do is to try and leave this tabbing on as well, just sort of like we have here, to establish the most forward end of that bulkhead. So that way as we're cutting the bulkhead, we have something to rest it up against, and we know that we're in the right plane. We'll cut this stern side, and we'll try to pry in and see if we can get the fiberglass to release from the wood, or probably more likely the wood laminates to release from each other, and let most of this bulkhead go, and then we can clean up that fiberglass tab. It's not imperative, but it's, well, let's give it a shot. Let's see how it goes. So this brace needs to get removed. Taking this off means that I don't have this platform to work on anymore. So I lose, looks like about 2.5, 3 feet. And it is what it is. Climbing around here is getting harder and harder, but hey, we've almost got this whole bulkhead out, so it's just a wet noodle now. But we keep on going. Actually, not sure I'll be able to get out of here. We'll see. There it goes. So in preparation for removing that forward bulkhead, these beams, they feel good. They appear to have some water staining on them. So I am curious to see what the water content is, if any. Got my little moisture meter. And we're looking at between 15, that's a little higher there, 22. What I'd like to do is sand these down, expose all raw wood. I'm going to put these down in a room in the house that has a dehumidifier in it. I'll just let them sit in there for a little while until we're ready to put these back in, and we'll cover them in a clear penetrating epoxy. Then they should last another 30 plus years. This is the forwardmost bulkhead that we removed from the bow of Antidote. I was aware that some of this wood was in bad shape, especially up here at the top, before I removed it. As it started to come out, it became even more evident that there was just a lot of moisture that had gotten into this wood over the years, and it was very compromised. Some of the top corners are okay, but most of it is in really bad shape. Now, this is a piece of 3/4 inch plywood that was put into the boat. It's about 5 feet wide by 6 feet long, and it was one piece when it was installed, so they had some access to some really large sheets of plywood. I don't know if you can get larger than a 4x8 plywood here. Maybe you can get 5x10s somewhere if you know the right people, but at any rate, we are not able to put this piece back in full size because there's only 2 ways to get it in, and one is through the hatch up top, which has a maximum opening of about 32, 33 inches, and then the companionway, and then down through that forward locker, which is a little larger, but not by much. So this is gonna have to get cut into at least 2 pieces. Allow myself to interrupt myself. I'd like to give you guys a better idea of what I have planned to replace this forward bulkhead. So you can see this is what we've started with. This is the old floppy piece of plywood that's delaminated and currently laying on my workbench. Now you might also remember that I had this head tank here mounted to port. And now you can see that I lose several inches of opening, and I also have this reduced strength here because this side is actually quite narrow, so is the top. This is only about 6 inches here on the side and on the top. So my idea is to make this opening as small as possible while still being functional. So I'm thinking something like this. So the top portion of this bulkhead was originally 6 inches, and that's not a lot, especially considering that the staysail is mounted just forward of this. Now, Bob Perry recommended that I had a 12-inch section using 3/4 inch plywood. Now, I think I can get away with 9 inches. That's what I have drawn here. That's about the most I can get away with before that hole starts to get too small. So stripping away the existing bulkhead now, we can see this is the original tabbing that's still in place. And you see here that I have this little rabbet or rebate. And this is just to help me line the 2 pieces up, make sure that they are in plane when I put them back together as I start to assemble this new piece. Now, one of the issues that I'm trying to solve with this is how to drain the anchor locker. Originally, this bulkhead was open to about here, so all the original water would flow underneath the bulkhead into the bilge. So my idea here is to seal this off completely and install a through hull that will pass water through the bulkhead and then attach to a hose to keep all the water contained. So this little angled wedge here is just designed to get the hose to come out and match the angle of the hull so that it's not going to present an obvious point to step on and probably damage. It'll just keep things out of the way. And this is an 1.25 inch through-hole fitting that I've designed this with, and that's just so that I can pass a substantial amount of water, and more importantly, dirt and debris can wash down through there, and I will be able to maintain it and clean it somewhat easily. You know, a 1/2 inch line is going to be very difficult to maintain and clean. So I plan on beefing up the floor inside the locker here. This will be a pretty small piece, but I will have a sturdy piece of fiberglass and maybe some foam below it just to support it that I'll install along the bottom, and this will be just to allow water to direct to the hole and also support the weight of the anchor rod. Now I'll design a similar wedge that mounts above the hole. This will be perforated, and also it has to be quite stiff and strong, and this will just allow the water to pass through but not any debris that is large enough to clog up the hose or the through-hole fitting. Now once all these fittings and components are installed and tabbed to the forward side by reaching over through this large opening, then I can start installing the rest of the system. So I'll install the top part of the horizontal bulkhead and tab that to the forward end. And then once that's done, I can install the two vertical pieces. This is now going to be a 1-inch bulkhead that will all be epoxied and screwed together. Once that's complete, I can tab the whole section on the aft side to the hull. I may decide to add this extra piece on the aft end across the top section, and this is a 9-inch by 1/2-inch piece of plywood, and this is just to further bulk up this top section and increase the strength and stiffness. 12-inch by 3/4, which was recommended by Bob Perry, will be similar in strength and stiffness to a 9-inch by 1.5-inch section, so that should be plenty strong, and I'm leaning towards installing this, although I haven't committed yet. From my rough sketches, it looks like all of these pieces will fit on 2 4x8 sheets of plywood. So let's get started on cutting out the horizontal pieces from OSB to test that they will fit into the boat to begin with. There's the first piece. And that's actually a reasonable sized hole. I can fit through it. Probably get a sail bag through there. I'll have to test one before I commit to that size. Okay, so this sail bag is a large furling Genoa. So would we be able to get this through the little hole here is the question. All right, success. This is a big asymmetrical. I don't think it gets used a whole lot, or hasn't been used a whole lot. And this one might be a little bit bulkier and weirder shaped, but let's see here. There we go. So the answer to both questions is yes. So we'll go with the smaller hole. This is the biggest thing I got to get through there. And I like the idea of the more strength this will provide, especially when it's doubled up. Cool. Not a lot of room to spare there. All right, so bulkhead test fit with the horizontal cut, and it fits pretty good. We'll get the foam in there, we'll lay that in with the chamfer on it, and then put this foam back, put the board back in, and just make sure the fit is still good. And if we like it, then we can start cutting out the actual marine ply and start glassing this thing in. From the reading I've done, some builders recommend putting a foam block around the perimeter of a bulkhead in a trapezoid shape, so that you support behind the bulkhead, and then on a 45, on the distance from the bulkhead to the hull. And what that does is sort of creates a fillet or a chamfer where the glass can transition from one plane to the other more smooth, and that also spreads the load out from the bulkhead onto the hull without creating a hard spot. I've talked to a few builders, Bob Perry as well as Aladino over at Sailing Magic Carpet, and we all kind of agreed that it is best practice. It's maybe not 100% critical, but it is a good idea. So I'll probably go ahead and do that. We've got the time. Let's do it. We have the foam now running around the perimeter of this tabbing. Just glue this in with some thickened epoxy, and that sticks pretty nicely. So by mixing the epoxy very thick, like really thick Vaseline, peanut butter, when you push the foam on, it actually kind of sucks it in and it doesn't release very easily. So I'm going to let the temperatures stay here. They're around 57 degrees right now, so I'm going to just let it be the way it is, let everything kind of gel. I've got a few hours until the sun dips down and things start to cool off. It's going to get to around 32, 35 degrees tonight, so I will need some heat in here just to keep the reaction going. So I'll put some heaters in here in a couple hours, and that way the extra heat won't let the epoxy sag. It'll gel where it is, which is what I want, and then after it's gelled, I can heat it up to get the full cure of the epoxy. Okay, the first lower bulkhead with the horizontal cut is fit to a point where it's ready to go in. We can use this pattern to now cut out the actual marine plywood. And the reason I wanted to use this cheaper OSB is just to kind of make sure that the concept works before I commit to the $100 sheet of marine plywood. These are only like $15 right now at the big box store. So let's get this cut out and we'll go from there. The next stage of the plan here is to use this rabbiting bit to take off a 1/2 inch section off this front edge. So here's a little offcut of the test piece, and you'll see that when these go together, there's just it's a little undersized, and that's to allow a little bit of epoxy to stay in the middle. So when I mix up a thick batch to go in between here, I'll screw it in until it's just flush, and that'll be really nice. Alright, so this is the test fit with the first actual marine ply panel, and the fit looks really good. So let's continue to work on the forward-most bottom part where we're going to have the drain. The following morning, and all that epoxy has had some time to dry. So we've got two parts to look at here. This is the block that we will machine down to be the tapered wedges that will support the through-hull fitting that will act as the drain, the anchor locker. It's 1.25 inch through-hull skin fitting, flush mount skin fitting. So the plan with this one is to roughly cut it along the diagonal on the bandsaw, smooth up the edges, then we'll have two tapered halves that we'll be able to glue on either side of the bulkhead. Let's get this thing cleaned up. Getting this through-hole fitting to mount nicely onto this block of wood is going to be a little bit of a challenge since I don't have a drill bit that can cut this profile out very easily. So we're going to use a series of hole saws and some other different bits to try to make approximately that shape inside this wood so I can flush mount it. Drilling that out now while it's a flat block is going to be super easy, and then we will slice the block in half in the wedge shape. Drilling the holes after the fact would be a lot harder, especially to get them totally flat and perpendicular to this plane. So we're going to drill them now and then cut the block later. So let's get to work trying to get this thing to fit. Okay, we'll do a little test fit here. Boom. Okay, that looks good. We're gonna put some fiberglass in there, bolt it all down. And the Marlon is supposed to bond to fiberglass. That's gonna provide a really good hole for the anchor water to drain out through. Awesome. We're gonna just trim these edges off now using the bandsaw. Get a close fit, we can polish it up with the sander, and then we'll go test it out, see how it looks. Cool. Well, that's all we've got time for today. I hope you've enjoyed today's video, and if you have, it would mean so much to me if you'd hit that like button and maybe leave a comment. Let me know what you think about this solution to drain the anchor locker. Come back next time where we'll be installing all of these pieces up at the bow of the boat, including the rest of the bulkhead components. Before we go, big thanks to the folks on Patreon that really do help make this production a possibility. You can go and check out the different benefits available to you there at patreon.com/livingforsale. And I'd like to give an extra big thanks to a couple that are supporting this production in a major way over on Patreon, and their names are now appearing on this screen. Thanks for coming by, guys. See you next time. Hi folks, welcome to a new day here. Yeah, same shirt, bear with me. Hope fashion police aren't watching.